Hey listeners, are you ready to uncover some extraordinary wonders? Disappearing Spoon is thrilled to partner with the amazing Curiosity Box. It's a science subscription service for curious minds. It's created by Vsauce, the internet's leading science education channel, with over 3 billion views. This season's box is packed with goodies that will fascinate and inspire you. Challenge yourself with a magnetic shadow alphabet puzzle. Piece it together to spell out the alphabet using only the letter shadows. Or discover the picture pot, where art and mathematics merge into a colorful, creative masterpiece. It is fun and educational. And the highlight, a sample of recreated Martian soil. Experience the thrill of holding the red planet right in your hands. Don't miss out on this unique adventure. Subscribe to Curiosity Box now and celebrate the incredible achievements of science. For 50% off, use the offer code SPOON at the-curiosity-box.pxf.io/disappearingspoon. That's offer code SPOON at the-curiosity-box.pxf.io/disappearingspoon for 50% off today. Unbox the mysteries of the universe with Curiosity Box. A fight nearly broke out right there in the fruit aisle. The setting was a grocery store in Peoria, Illinois. The owner of the store, John Scouteris, prided himself on stocking fresh, healthy fruit. But that day in 1943, he found a moldy grapefruit sitting out. He quietly palmed it, then slipped away to dispose of it. But not before a customer caught him, Mary Hunt. And to Scouteris' horror, Hunt called out, "Wait, is that moldy?" Scouteris could have died. He hid the grapefruit in his apron and hissed, "No." But Mary would not listen. She marched over to see it. By now, other customers were looking. Scouteris started sweating, pleading with Hunt to zip it. But she insisted on seeing the grapefruit. She claimed it was a matter of national security. National security? Scouteris thought she'd gone soft in the head. But then he remembered that Mary did work in a government biology lab. Mary then doubled down. She told Scouteris that moldy grapefruit could win the war for the Allies. Now, this sounded unlikely. But to get her out of earshot of other customers, Scouteris steered her into the back to chat. And what Scouteris could not have known was that this tiff, and his decision to indulge Mary Hunt, would indeed arguably win the war for the Allies. Mold was our secret weapon fighting Germany and Japan. Why? Because that mold produced one of the most important drugs in history. None other than penicillin. From the Science History Institute, this is Sam Keene and the Disappearing Spoon, a topsy-turvy, science-y history podcast, where footnotes become the real story. This story idea came from dedicated listener B in Minneapolis. Most people know the story of penicillin, or they think they do. This story involves Alexander Fleming, whose life highlights the importance of being a slob sometimes. He's the ultimate rejoinder if someone nags you to make your bed or tidy your desk. Fleming was a short, quiet Scotsman with bright white hair. He studied microbes, and he kept a filthy lab in London. In September 1928, he took a 2-week vacation and just didn't bother cleaning up before he left, essentially leaving dirty dishes in the sink. Glass plates and petri dishes smeared with bacteria were everywhere. After his holiday, Fleming found fuzzy green-gray mold growing in some dishes. This was gross even for Fleming, so he decided to toss them out. But before he did, he noticed something. One plate was dotted with bacteria colonies he was studying, little circles like fried eggs. The dots were everywhere on the plate, except near the lump of mold. There were no bacteria near the mold. They had all died. Despite his lazy habits, Fleming had a quick mind. He realized that the mold must be producing a substance that killed bacteria, some sort of antibiotic. If so, that would be huge news. It's hard to put ourselves in the mindset of people back then, but doctors essentially had 0 treatments for most infections. If you caught pneumonia, or rheumatic fever, or gonorrhea, either your body fought it off, or you were a goner. Even little scratches became death sentences. So if Fleming found a substance to kill bacteria, well, that would revolutionize medicine. The mold on the plate was called Penicillium, so Fleming called the killer substance it secreted penicillin. In most people's minds, the story ends there. Fleming discovers penicillin and hallelujah, it saves the world. Not quite. The discovery occurred in 1928 and then nothing happened. Fleming never did make anything more. Sure, he tried to extract the penicillin molecule to make a drug, but as a biochemist, he was pretty clumsy and he botched the job. He never isolated the molecule. Equally bad, Fleming was a terrible public speaker. He gave a presentation on the work and he made a hash of it. He was mumbling and wandering instead of getting to the point. So when he published a paper later, people remembered the talk and just yawned. No one read it. His discovery therefore languished for a decade, and in that decade, no treatments were developed. No lives were saved. In fact, penicillin might still be languishing today, if not for an English-Australian biochemist named Howard Florey. Florey looked like Clark Kent. Strong chin, strong hair, spectacles. Florey worked in a hospital lab, and he saw people dying every day of infections. He was determined to help them. Florey had a few crucial traits we don't normally celebrate in scientists. First, he was good at bureaucracy. He knew how to finagle grants and manage prickly scientists. Second, Florey had a high tolerance for tedium. To search for leads on fighting infections, he regularly flipped through mountains of dusty medical journals, scouring for anything that might help him. It was boredom incarnate. But his doggedness paid off in 1938 when he came across Fleming's article. It electrified Florey. He grabbed a German biochemist in his lab, Ernst Chain, a plump fellow with a walrus mustache. Florey told Chain to get some penicillium mold and find that penicillin molecule. Now, by all accounts, Chain was a complete jerk. Colleagues called him abrupt, abrasive, severe, but he flourished under Florey's management, and no one could deny Chain's skills at the lab bench. Chain started producing so-called mold juice. He'd grow some fuzzy mold in a dish, then flood it with water to extract the various chemicals that the mold was making. Chain then ran the juice through chemical and physical filters to isolate the molecule he wanted, penicillin. Again, this was excruciatingly boring. Chain had to process gallons upon gallons of mold juice, drop by drop. And after all that work, he had mere milligrams of penicillin. But it was enough to test the drug. In the summer of 1940, Florey and Chain infected 50 mice with deadly strep bacteria. Half received no treatment. They died. The other half got penicillin. They lived. Now, you just don't get results that good in pharmacology. Improvement rates of 10% with certain diseases could mean a blockbuster drug. Meanwhile, penicillin was infinity times better. There was just one problem. Mice are tiny, and treating them had required months of work from a world-class chemist. Isolating enough penicillin to treat a human would require even more labor. But Florey was determined. He started growing whole lawns of mold and storing the extracted juice in anything he could find: bottles, buckets, bedpans. The lab began churning through 500 liters of juice per week. That's 250 2-liter pop bottles, a whole grocery store's worth. A few months later, they'd made just enough penicillin to treat one person, and then a perfect case fell into their laps. The case involved a 48-year-old policeman named Albert Alexander. On weekends, Alexander liked to potter around in his rose garden, and one day he scratched his cheek on a thorn. It had happened a dozen times before, but this time the scratch got infected with aggressive bacteria. Alexander checked himself into the hospital, but the wound festered and spread to his scalp. Then it metastasized to his lungs and shoulder. Pus-filled boils appeared inside his eyes. He lost one eye completely, and his doctors watched all of this helplessly. Florey and Chain heard about Alexander, and they asked permission to try penicillin on him. Alexander's doctors said, why not? What else could they do? So in February 1941, they injected Alexander with 160 milligrams for 5 days, then stood back to see what happened. What happened was, in a word, miraculous. Alexander's immune system, honed by 1 billion years of evolution, had been overwhelmed by the infection. Every drug in the hospital's arsenal had proved completely impotent. But the mold juice? It kicked that infection's butt. Almost. After 5 injections, Florey ran out of penicillin. The infection came roaring back. Florey's lab scrambled to make more, but they just couldn't move fast enough. Within a week, Alexander had died, done in by a rose. This sad case drove home both the promise and the peril of penicillin. It was a bona fide miracle, but nearly impossible to produce in large quantities. And that crisis seemed all the more acute because of the looming World War. During World War II, bacteria scared the Allied military almost as much as the Nazis did. When we think of war deaths today, we imagine people getting mowed down by bullets or something. But for most of history, soldiers were far more likely to die of diseases in their filthy camps than they were of bullets, swords, or arrows on the battlefield. Less lethal injections caused problems too. Frankly, soldiers were young and reckless and caught sexually transmitted diseases. So-called short-arm inspections were a regular feature of military life by World War II. And doctors estimated that the Allies would lose millions of man-hours of soldiering to STDs, the equivalent of leaving a dozen aircraft carriers sitting at home. Allied doctors had to find a way to combat infections. And Howard Florey knew that penicillin could do that, if only they could make enough of it. He begged British leaders to help him. But British industry was too strapped then just fending off the Nazis. So they put Florey in touch with scientists in the United States, specifically in Peoria, Illinois. Peoria housed a U.S. Department of Agriculture lab. Florey visited there in the summer of 1941 and outlined the promise and peril of penicillin. Again, the drug could stop most infections, but the strain of mold they were using to make it simply did not produce enough of the molecule. It merely dribbled penicillin out. They needed something that gushed penicillin. The scientists in Peoria agreed to take over penicillin research, and especially to find a more productive strain of mold. They started writing colleagues across the world, asking for samples of molds. They were determined to scour the earth, from the Himalayas to the seashores, to find the best penicillium possible. But it turns out, they need not have worked so hard. It took a few years, but the best mold they could find popped up right there in Peoria. And it was discovered by one of their own scientists, Mary Hunt. If you haven't heard of Hunt's role in penicillin, you are not alone. She remains unjustly obscure. Hunt had thick brown hair, heavy eyebrows, and a button nose. She was born in Eastern Europe and immigrated to Chicago at age 3 with her parents. She studied nursing and public health in college, then trained in bacteriology. She worked in science at a time when almost no other women did, but she had a few ace skills. One was a good eye for interesting molds. So while her bosses were begging for samples from Mongolia or wherever, Hunt decided to survey Peoria, wandering into bakeries and fruit stands, which is how she found herself confronting grocery store owner John Skouteris over a moldy grapefruit. Now, Skouteris had every right to be upset with Hunt for blabbing about the moldy fruit in public. Grocers live and die by their reputation for cleanliness, and here Hunt was hollering about mold. In fact, she kept asking if he had other moldy fruit. But something about her urgency convinced Skouteris to trust her. And to get her away from the other customers, he steered Hunt into a back room at the store, somewhere the public was not allowed. There, Skouteris lifted a hamper, and like an archaeologist glimpsing a glittering treasure, Mary Hunt's eyes went wide. In the hamper were dozens of moldy fruits, apples, bananas, pears. Skouteris defended himself, explaining that this happened to all grocers. You can't eliminate mold. All of which was music to Hunt's ears. Here was a motherlode, a bonanza of mold. She made Skouteris promise to save every moldy fruit he found. It was vital for the war. Risking his reputation, Skouteris agreed to. As for what took place next, we don't know if it happened a day later or several months. But at some point, Skouteris set aside a cantaloupe from Texas with some mold on it. Shortly after, Hunt came by to collect. By all accounts, the cantaloupe was a beauty, luscious and ripe. And the mold wasn't bad, just a whisper of fuzz around the navel. But it enchanted Mary. She had never seen anything like it, and she whisked it off to her lab to culture it. This was not an easy job. As one scientist recalled, Penicillin mold is as temperamental as an opera singer. But Hunt had skills, and she grafted the precious fuzz onto a nutrient-laden plate to culture it. Oddly, Hunt then sliced the cantaloupe up and served her colleagues lunch. They agreed it was delicious. And over the next several days, that wisp of mold changed medical history. It grew into a lawn, and they extracted some mold juice. And for whatever reason, that cantaloupe's fuzz produced 200 times more penicillin than Fleming's original mold. This was a game-changing figure. 200 times the drug, 200 times the miracle. The Peoria lab then used various tricks to goose the production still higher, by a little. But their tweaks paled compared to Hunt's quantum leap. Before long, penicillin production became an industry. In 1941, Ernst Chain labored for months to produce 5 doses of penicillin. By 1945, Hunt's mold was producing 600 billion doses every single month. As a result, deaths by infections plummeted across the military. As one example, bacterial pneumonia killed 1 in 5 infected soldiers during World War I. During World War II, it killed 1 in 100. We normally think about radar or atomic bombs winning World War II, but penicillin was arguably the decisive factor. Civilians benefited as well. To date, penicillin has saved an estimated 200 million lives across the world. It's also halted countless numbers of painful, disfiguring ailments. It's no exaggeration to call it the most important drug in history. And it all started with a moldy cantaloupe and a woman who would not take no for an answer. Mary Hunt went on to run a lab in Long Island before retiring to Arizona and dying in 1991. So why does no one know about Hunt today? Or for that matter, why don't we know about Howard Florey or Ernst Chain? We just hear about Alexander Fleming. Why? I think it's a human bias for good stories. Florey's bureaucratic skills and plotted doggedness, they just make us yawn. And while we might praise the technical skills of a Chain or Hunt, we really don't care that much. Such skills are less sexy than, say, Alexander Fleming's flash of insight. But flashes of insight are just that, flashes. Real science, real life-saving drugs would never get made without the plotters and technicians. Still, I do think there's something more going on with the neglect of Mary Hunt specifically. Fleming obviously became famous, but Chain and Florey at least shared the Nobel Prize with Fleming in 1945. Meanwhile, Mary Hunt wasn't nominated for the prize or even mentioned by the others. In fact, years later, the top officials at the Peoria lab could not even remember her last name. They just remembered a woman they called Moldy Mary. It's a pretty damning indictment of how women in science got treated then. Obviously, Moldy Mary is not the most flattering nickname, but Hunt didn't mind. You see, she had a different perspective on microbes. To her, they were not gross or icky. They were a vital part of nature, even something we can harness for our own good. A few minutes ago, I jokingly suggested that you should bring up Alexander Fleming's sloppy lab whenever someone chides you about a cluttered desk. You can actually do the same sort of thing with Mary Hunt. The next time you find a moldy peach or whatever in your fruit bowl, by all means, toss it out. But take a moment to appreciate it too, and to see the world through the eyes of a woman who saved 200 million lives. This is the Disappearing Spoon podcast, brought to you by the Science History Institute. Find out more about their library, museum, and multimedia magazine at sciencehistory.org. Make sure you check out the Science History Institute's other awesome podcast, Distillations. You can find their in-depth narrative stories and interviews about everything from space junk to sex, drugs, and migraines, anywhere you get your podcast, and on their website, distillations.org. You can find more incredible stories from my books at samkeen.com. You can also book me as a speaker at your school or event. If you like this podcast, please support it at patreon.com/disappearingspoon. It costs as little as 7 cents per day. You can also get bonus episodes and signed books. Please spread the word to others as well, and subscribe in iTunes, Stitcher, or other places. This episode was written by me, Sam Keen. It was mixed by Jonathan Pfeffer and produced by Mariel Carr and Rigoberto Hernandez. Thanks for listening.
This message comes from our sponsor, Teladoc Health. There are lots of reasons for wanting to be healthy. Family, work, living a fuller life. Teladoc Health understands. Whether you have diabetes, high blood pressure, or just need to manage your weight, Teladoc Health can help. Visit teladochealth.com/whatsyourwhy for more information. That's TELADOC health/whatsyourwhy.